Thank you for coming to this Changing Planet seminar hosted by Imperial's Grantham Institute. This session will be recorded, and if you're part of the DDP, the codes are dotted around the tables to register. It is my pleasure to welcome today our speaker, Professor Guy Howard from the Cabot Institute at the University of Bristol.
Great, thanks, Becky. So just checking everybody can hear me in the room and hopefully they can online. Let me just say a few words about me. So as you'll see there, I'm the director of the Cabot Institute for the Environment at the University of Bristol. I also hold a research chair in environmental and infrastructure resilience based in the School of Civil Aerospace and Design Engineering. I've been in Bristol now for about 4.5 years. Before that, I spent almost 16 years in what was the UK Department for International Development, working primarily on water and sanitation, but also on climate and environment issues and wider infrastructure issues. So I was policy lead on WASH for about 6 years, and a deputy head of the Human Development Department, amongst other things. And before joining DFID, I spent several years in academia, before then about a decade in academia. The reason why I mentioned that is that I don't have a traditional academic profile. And so a lot of my research and a lot of my interests probably reflect much more that I like to work very much on the research and policy interface. So I'm not a pure academic researcher, and I find myself drifting off when I meet too many people who are very academic researchers, and I'm no longer a true policy wonker, and I equally drift off when people just start going too far in the policy area. But that gives a bit of a framing about what I'm going to talk about today. So this presentation it's an interesting one for me. So quite often when I'm giving this presentation, I'm giving this to people who are what would be termed WASH specialists. And can I just check, when I use that term WASH, how many people understand what I mean by that? Okay, so there's a few around the room. So what that means, for those who didn't put their hand up, is water, sanitation, and hygiene. So it's about provision of basic services of drinking water supplies or water supplies for domestic purposes, sanitation, so the removal of excreta and safely managed sanitation, and hygiene, which is around a whole set of behaviours. So usually I do this to WASH people. I'm trying to make sure they try to grapple with some of the things about where they think about climate change. Today's going to be slightly different, so I suspect you much more come from the climate perspective, and so I need to make sure that I'm communicating the WASHy bits a bit more clearly. Anyway, what my talk is really going to be about is why is climate change important for water and sanitation and hygiene? How are we starting to look at resilience, particularly with a focus on low and middle income countries? And how do we start looking at net zero? And how we think about water and sanitation services as something, as a sector that needs to achieve net zero, and how might it do that, and what are the drivers? What I hope to get across to you today is a real sense that actually sectors like these are really priority sectors where action really needs to happen, and it needs to happen urgently. And it's partly because what we know more broadly is that access to water and sanitation, along with access to things like healthcare and education, are critical to community, society, and economic resilience. And in fact, it's when you start to see a lot of those services that you start to see more broadly that communities and societies and economies become less resilient. But in order for these services to play that role, they themselves will need to be resilient to climate change. They don't get a out of jail free card. You know, they are as affected by climate change as everything else. So let me start. It probably would help if I use the right piece of equipment. Use any equipment. Can anybody advise how I do that?
Alexa, the arrow next to that.
This one? Is that? No? Okay, yeah, no. flowers are clear. Right. So always good to have a slight technical hitch early on. It's been one of those days. I've had cancelled trains, late trains, Microsoft just deciding I didn't have any rights to use any Microsoft products today. So that was a minor one. So why do we worry about climate threats? So what are the problems we're worried about? Well, the changes in climate are going to pose major threats, and that's going to lead to challenges around water quality and water quantity. And so the issues around water quality will be things that will change the treatability of water, will make it more difficult to treat water. It may introduce new chemicals and pathogens that we haven't typically had to treat before. It will affect the ability of our wastewater treatment plants and the performance that they will need to achieve, because the dilution potentially available in receiving waters reduces. And it will affect water quantity. And water quantity both affects the amount of water we can supply people, but has important implications for sanitation as well. As I've said, when we treat wastewater, we discharge it into natural water bodies, and most standards are based around those natural water bodies having a certain carrying capacity, i.e. they can absorb a certain amount of pollution and dilute it to levels which are then safe. Very often, climate change is going to mean that there's going to be a mix of problems. So you will get water scarcity will not just reduce quantity, it will also introduce new water quality problems. And likewise, very degraded water quality may reduce the quantity that is available. What we already know is that climate change causes a major risk for interruption of services. So people now can lose access to those services. That greatly increases the risk to their health through the transmission of infectious diseases. But that interruption of services could be because of cascading and multiple hazards. So what I mean by that is you get a nice rain or snow event somewhere that triggers a mass movement of the snowpack. You then go into a landslide that goes into a reservoir, which then is overtopped, and then you get a flood, which then washes away your infrastructure downstream. And all these changes have important implications around infectious and non-communicable disease. And the basic principle of providing safe drinking water and basic principle of safe sanitation is that we are trying to prevent disease transmission. I mean, that's the fundamental point of doing it. So I'm not going to go through all this, but what this tries to illustrate is just the extremely wide range of climate change related hazards and how those will impact on water and sanitation services. So that goes around from everything from a loss of permafrost and permafrost melting to glacier melt, to rainfall and flooding, reduced water, saltwater intrusion, changes in surface water temperature, and wildfires. So all of these things will have effects on water. Some of them are quite well studied and understood around flooding. But things like glacier melt, for instance, we're only just beginning to realise that if you look at places like the Andes, key consequence of glacier recession is the release of toxic metals into water. And in lakes, glacial meltwater lakes, and particularly chromium as a particular problem becomes there. There are studies increasingly showing that in permafrost, in the Arctic, for instance, where people traditionally have allowed sanitation and water supplies to be separated by relatively short distances because there was essentially no horizontal movement of water at the subsurface. As the permafrost thaws, you suddenly start creating transit routes through the subsurface. So what you previously thought was a safe distance is no longer a safe distance. Things like saltwater intrusion is not just about sea level rise. This can be a consequence of short-term storm surges. So there's an event in the Marshall Islands and the Pacific Islands where one storm surge caused saltwater contamination with freshwater lens, which was used for drinking water, and it took 3 years before that lens returned back to normal equilibrium. So these are long-term major effects. So if we start to think about these hazards, we start to think about these threats, and then we have to think about resilience. Well, what is resilience going to entail? So if we're going to try and build resilience, we're going to have to think both about rapid and slow onset events. So what I mean by that is a flood is a very rapid event. A flood happens very, very quickly. It inundates your systems quite quickly, but it also goes away quite quickly. But slow onset things like droughts take a long time to be felt. So they are not immediate effects. They may occur over weeks, months, or even longer. Very often you'll find that these are multiple threats, and you'll find the same place will be affected by these threats repeatedly. So there are parts of the Somali region, for instance, in Ethiopia, that have suffered prolonged drought, followed by very, very severe flooding immediately afterwards. And that is not uncommon, and that will become increasingly common across the world. The thing that I wanted to point out on this graph, and this actually is a graph that was adapted from a document that we helped prepare for about climate resilient healthcare systems and healthcare facilities, is really what you need to look at is that dip in performance, which may be as a result of a shock, or it may be a result of a slower onset stress. But the point is, when you get these climate threats, the performance of your services decline in the short term. And hopefully they don't decline too far. They still remain acceptable, they may go below average, and they may get very poor. And ultimately, your resilience is the ability to which you build those systems back to go back to their previous level of functioning, or preferably higher. But the point about this means that you increasingly need to think about disaster preparedness and emergency response in terms of service provision. Because when you get major events, your services will stop functioning in the way that you think they will, and they will increase threats to public health. And this area, this whole thing about emergency preparedness and response is something that people who work in routine services, by and large, are not thinking about as much as they should be at the moment. And it always seems to catch them out, and they get quite surprised that they now have a problem and now have to start trucking water in. What does that look like? So, for instance, in 2007, big floods in southwest of England. The Mythe pumping station just outside Tewkesbury got flooded. That knocked out water supply for most of Gloucester for the best part of 3 weeks. So about 300,000 people had to rely on bottled water for about 2 to 3 weeks. So this is what we mean by what you need to do is to think about your preparedness. What we also increasingly understand is that trying to build resilience in much smaller systems is going to be very challenging. So it's one thing if you're quite a big utility. I was going to use Thames, but that's not a very good example at the moment. But you could be, if you're a big utility like United or Severn Trent, you have financial, human, and technical resources that will allow you, hopefully, to be able to plan ahead and to put in place response plans and think about how you build resilience. We're very small suppliers, which is the typical kind of thing you find through a lot of small towns, rural areas, and peri-urban areas in low middle income countries. You also find it in rural areas in places like the UK. It's very challenging because those tend to be systems that have less money, they have fewer people, they almost certainly have fewer trained technical people who will be able to understand threats and wouldn't necessarily be able to do all the technical responses you expect. This goes back a little bit to the slide I showed before. One of the issues you find around water sanitation is that floods and droughts are the things that everybody thinks about. I'm sure in this room, if I said to you, well, what do you climate change mean to the water supplies, you would say, well, floods and droughts are the big things you need to worry about. They're the problems. And in some ways they are. They are the most common threats, and they're certainly the ones that are most commonly looked at. But there's a whole set of issues that people are not necessarily looking at and need to pay more attention to. So wildfires, for instance, are increasingly occurring. So when wildfires happen in catchments, they fundamentally change them. short term, sometimes in the long term. They change the hydrology, they change the water quality. They also lead to damage to power and other auxiliary services. And just to give you an idea of the importance, I think last year was something like 10,000 wildfires in the UK. And the UK is not a particularly dry or particularly hot place. I mentioned melting permafrost. Algal blooms is another big thing. So when people think about algal blooms, they think about risks around toxins. But actually, the bigger problem with algal blooms is that they completely clog up your water treatment processes and systems. And it actually makes it very difficult for you to start treating your drinking water. I mentioned about storm surges, but also ambient temperature, just as it rises, that starts to interfere with basic biological processes that you rely on to keep wastewater. So your wastewater treatment efficiency starts to reduce. So the point about this is increasingly trying to get people who are thinking about water sanitation, thinking about climate changes, don't just look at the usual suspects. Yes, flooding is very important. Yes, drought is very important, but these other things are also very, very important. So the kind of actions that we need to think about are, obviously, as I said right from the top, is we want our services to be resilient, to provide wider societal resilience. And that very often means adaptation. But again, I think one of the misconceptions that people have is that adaptation automatically means new infrastructure or new technology or some kind of new innovation. Actually, most of the time it doesn't. What it really means is people doing sensible things around managing catchments, managing their environments, managing the existing technologies and infrastructure they have better, being much more adaptive in their management, so having adaptive management systems that are able to flex depending on how the threats are changing. And increasingly what we're seeing are people looking at economic and regulatory instruments to provide the right types of incentives for suppliers. And in some cases, there's work that is done around end user behaviour, so particularly if you're trying to limit how much water people use. That tends to be less of a problem in many of the places where I work, but certainly if you think about places like the US and bits of the southwest US, end user behaviour becomes very important because their per capita consumption of water is extremely high. And so actually, if they're going to adapt to climate change, they almost certainly need to reduce their per capita use of water. And increasingly, resilience is being understood about being a mix both of the adaptation that you put in the services, but also how you work towards reducing your emissions and you work towards net zero. And I will come back to net zero towards the end of the presentation. You're not a WASH crowd, so you probably don't necessarily know. So for a long time, there's been this discussion about, well, you know, isn't resilience just about sustainability? Isn't it all just one big, you know, isn't it all just a big frame? And it's not. And the way I always tend to frame it is kind of using, well, Donald Rumsfeld sort of basically paraphrased the Johari window, which is basically, if you think about sustainability, you're thinking about known knowns. So you're thinking about, you know the stuff that affects sustainability, you know what you should do about it. Whether you do those things or not is a different matter, but you do know. And resilience is more about your unknowns. So it's your known unknowns, by which I mean, you know you're going to get more flooding, but what you don't know is its intensity, change in intensity, changes in frequency. And it's also about your unknowns. So that might be an example if you're in an environment that's never experienced wildfire. An unknown would be a risk of wildfire and what that would mean for your catchment and for your services. And essentially, increasingly, what I'm trying to say to people is that what you're trying to do is operationally get yourself so that you're moving away from your unknowns, and you're knowing all these things, and you're increasingly moving towards known knowns. Because once you've got known knowns, that's much easier to manage. It's much easier to put in place systems of management to cope with that. The further left you go, the harder it is, because you're then trying to scenario plan, speculate, think about what you might do. And the pictures are just a way of trying to illustrate what might be true of those. So on the left there, that's Ben Nevis. It's called Winter Gull, and as you can see, this was a photograph about March time. A few years ago, there's a wildfire right in front of Ben Nevis, which, given the Ben is one of the wettest places, certainly in northwest Europe, gives you an idea about why a wildfire is in Australia. Your picture here is more about what we know how it's going to flood, but we don't know to what level and what intensity. And this is this is when we're starting to put in flood barriers, so we're coping. So I think it's a message I'd like to get across to you is that whilst resilience is important, operationally, actually you want to get people less worried about resilience and more focused on sustainability. But to do that, we have to make sure people understand what they're doing. So, kind of key question, I mean, I wonder if we can I just reduce that, because this box is quite important. So the critical question then is, how will we ever know if we've achieved resilience? And certainly in the water and sanitation sector, this is something that is causing a lot of debate, because we have quite a robust global monitoring system around water and sanitation, access to water and sanitation, and people are very keen to start integrating measures of resilience. But the problem is, too often, they're trying to look at resilience as an outcome, rather than what I would argue is resilience as a process. And the danger is that when people start to think of resilience as an outcome, you start to put in place very reductive measures. You start to say, right, so we will be resilient to a 1 in 200 year flood. And as soon as you set that as a target, almost certainly then in the next 20 years, you'll have a 1 in 250 year flood, and it will wipe out all water supply. And everybody say, but you told us it was resilient. Saying, well, yeah, we've not to that kind of level. The point about resilience is it's about getting people to understand an uncertain, changing world and being able and willing to adapt to it on an ongoing basis. And that's increasingly important because climate change and the hazards implicit in it are increasingly becoming unpredictable. So some of the levels of flooding that we've seen over the last few years are frankly really quite unprecedented. They're even with the concept of stationarity being dead, which is what hydrologists talked about 20 years ago. Even so, people have not necessarily predicted that the level of flooding that we would see now is what we have ended up with. And I think the point about putting this definition in there is that becomes really important, because what we're trying to say is that what you've got to do is to get your systems to be able to cope with these trends and disturbances and allow it to both maintain, but also in some cases just work to restore its basic function. And the last bit being critical is the capacity to adapt, to learn and transform. Now, this is taken from the IPCC. I imagine a lot of you are very familiar with it. I would also argue that an awful lot of people who work on resilience, we all know this. How much it actually is done in practice, I think, is very much more of a moot point. But we need to, going back, we need to think about how we measure resilience. And so what I'm going to talk a little bit more now is about some work that we've done, and this, in particular, development of some new metrics for assessing resilience, which for the first time these were done for low and middle income countries. But they also broadly reflect work that's been done elsewhere. So if you look at the US EPA website, creating resilient water utilities, they also have some very good examples around adaptations in big utilities in the US, which follow these same principles. And basically, the core thing about if you're going to have indicators of resilience is that you need to have multi-dimensional. You can't just get fixated on is my infrastructure going to be resilient? Is my environment well managed? Because actually, in the end, as with most systems, it is very much tied up with lots of different things. So you need to think about environmental setting and how you manage those. You need to think about how you design, build, and manage your infrastructure. You need to think about how you're managing it. Are your management systems robust, which includes financial management? And are you able to respond to operational challenges? You need to think about governance and engagement and accountability. And to what extent are the providers of suppliers, whether those be utilities or whether those be members of the community, are they being accountable to the people that they are expected to serve? And are they having a genuine open conversation with them about the needs? When you think about institutional support, and this is on the basis of an awful lot of particularly smaller water suppliers and particularly in low and middle income countries, the level of capability in the management of systems is very limited. And so what you need is external support from government or from third sector organisations that provide ongoing technical capacity in building and support. And critically, you have to understand your supply chains, because it's fine to have a nice, well-run water supply that is able to cope with all the floods, but if you only have one road in and out of that community and the road washes away or gets destroyed by a landslide because of rain, you suddenly cannot bring in the chlorine you need to treat the water, and the safety of your water will start to decline very rapidly. And with sanitation, it's the other way around. You can have good sanitation systems with people who come and empty your pit latrines and septic tanks. But again, if the roads wash away, they're not accessible, your resilience of that system is immediately compromised. So it tends to be relatively qualitative rather than quantitative, or it's probably more like semi-quantitative rather than just purely qualitative. When you have utility supplies, you can do very tailor-made assessments. So I've mentioned the US EPA website before, some very good examples where places like Seattle, where people have got a whole adaptive management plan with triggers about when they would do things differently. But for small systems, you can't do it for every individual system. You probably can't rely on the manager of that system to do it. So what we've worked on is developing simplified metrics that allow you to compare across multiple different sources, so you can identify priority communities, but you can also identify where you have systemic problems. So the metrics and what we've worked on is trying to develop relatively simple, even if they're going to be underpinned by large data sets, be transparent in the system of scoring, and to support decision making at multiple levels. And this box on the right gives you an idea about how you can use this. So it's about prioritising communities, it's about systemic failures. It can also be used at a very local level, some of these metrics, to work with communities as a scorecard. So engaging people in a debate about, well, what are the things that you will do on your system to make it more resilient? So what that led into is what's called the How Tough is Wash framework. And you can see here, the first two, a couple of papers. The first one is describing the metric itself. The second one is how it's applied in 2 countries, in Ethiopia and Nepal. And the third one is related around a scoping review around water quality and climate threats. So this was a good example of a metric. It was based on a 2-year project to develop this metric, to look at small water supplies and sanitation in low and middle-income countries. It was done as a collective partnership between Bristol, Haramaya University in Ethiopia and Kathmandu University in Nepal, working as a group to develop the metric, to go and test it, and then to engage people with it. And it looks at a range of different types of systems. Why did we choose those 2 countries? Basically because they have a very large number of small systems, which are primarily community managed, which have quite limited sort of international support. Both are very vulnerable to climate change, but for different reasons. So Ethiopia historically has focused on drought, but floods are an increasing problem in Ethiopia. And Nepal, obviously you have floods, you have landslides as a major threat, and they have particular issues in the long term about decline of availability of water in their springs, which is linked to glacier melt, basically. So it was a process where we were collecting data through quantitative means. So we used a lot of data from communities, using focus group discussions, key informant interviews around certain things like management, around governance, around supply chains and institutional support. That was backed up with some geospatial analysis to look at catchments, and then some sanitary inspection and sanitary risks assessment through data collection on the ground. And that was also underpinned by a set of climate storylines that we developed. So we did some modelling and on about a 30-40 year time horizon to see how the climate would be anticipated to change in different countries, and then converted that into what we thought that would mean in terms of the threat that would pose ultimately to water supplies. So, as you say, it's a scoring based on Likert scale, and you can see the types of systems that it was designed for. And what this gives is an example about, we're talking about Likert scale, you're going from 1, very low resilience, to 5, very high resilience, and you've got a definition of what those different categories mean. So essentially you do this, and we did this for each one of the 6 domains, which allowed us to develop an overall score for resilience. It also allowed us to track trends and track problems where we weren't seeing. And as I say, more of this is in detail in the 2 papers I flagged up before. I will obviously share the slides with you, and all those papers are full open access if you want to look at them. And what does that lead you to? Well, what it allows you then to do is to start producing data sets of all the systems that you're looking at, where you can start to sort of say, okay, how would I categorize these overall? How would I prioritize these? So obviously, if you've got systems that you're saying, actually, when I look across the piece, these systems are largely pretty resilient. You would say, well, I'm going to spend less money and less time here early on. And where I'm going to put my energies, first of all, is up here. In these systems that are least resilient, where they have more problems and more sustained problems. And in some ways, this approach builds on very much the approaches that were developed around water supply surveillance, which used a very similar kind of way of combining different data sets to arrive at a decision-making matrix and a decision-making tree. What you can then do, and what we looked at then, is how resilience was varying within each of these domains, and that's important because if you see that there is, or a domain has a consistent score right across the piece, whether it's high, low, or medium resilience, it tells you whether there's a systemic problem or not within that. And if you get consistent low resilience scores across that domain, you know, okay, we have a problem here, it's being replicated across multiple different communities, multiple different suppliers, and we need to go back and address that. Where you have much more variation, it's more complicated, because that then will tell you, well, actually, this is probably quite unique, probably context specific, and we would have to think about how we responded to those. What we were able to do, and this is the way you can start to identify the systemic problems, is that we started to look at the trends of the different domains. And so what this then starts to tell you is, okay, if you're going to place a lot of effort, where I'm going to place my effort around systemic problems are ones where I see a consistently low score. So you can see across the board, there is a consistent problem with a lack of institutional support. You can see supply chains are weak and management is weak. So that would tell you that you have a systemic problem right across your water supplies in the pool, that you actually need to address these things quite substantively. And it's different in different countries, so you get a slightly different pattern in Ethiopia. But the value of that is that you do your prioritization about communities, but this is also a way of telling you where you have these system-wide problems that you really need to invest in and address. And it's not just a case of going to one community or another community. This is about thinking about more fundamentally how you are supporting these supplies to function and how you develop your water and sanitation systems. So we had initial projects, as I say, in Nepal and Ethiopia, the development phase. This is now subsequently being applied to multi-village pipe water supplies in Ethiopia. I'll talk a little bit more about those in a minute. In Mozambique, this was used around a rehabilitation project. So big NGO called SNV was rehabilitating quite a number of water supplies that had been damaged by Cyclone Idai. And they used the House Office wash metric to understand what they needed to invest in, and once they had done the upgrade, whether they thought that they were coming out with more resilient systems. We're doing more work now in Indonesia with a focus on rural water supplies, and there's programs ongoing in Malawi, again looking at small water supplies to actually look at how we start to build resilience. And you can see there's another set of things that we're talking about working in Cambodia, Papua New Guinea, working with water for people, the sector monitoring tools for India and Peru, and then trying to apply it at a larger utility scale for a big water supply in the capital city of Uganda and Kampala. And what this metric has done is that this has started to inform the debate around global sector monitoring. So almost certainly now there's going to be a process where there will be WHO and UNICEF that jointly run the joint monitoring program. WHO does the GLASS report for UN Water, is looking about how resilience can now be better captured in global sector monitoring. That's important because those monitoring tools do actually have quite an influence around investment patterns, both in donor agencies but also country agencies. And hopefully they'll go off and improve it, which is amazing. The experience with this has been very interesting. So we initially developed a 5-point scale for each domain. When we subsequently tested this more with Ethiopian partners, looking at the multi-village supplies, they said actually in the field often you could also reduce it down to a 3-point scale, and that was more accessible, it was more understandable for people. People often find it quite difficult to differentiate between low and very low and high and very high. But still having that same way of being able to rank systems. I think a 3-point scale is obviously going to be more accessible for more people. I think that's fine. I think once you get to larger data sets, you probably do need to go to a 5-point scale, because you then probably do need to be able to differentiate more at a more granular level. And I think a cruder level of a 3-point scale risks missing out some really key problems. But I mean, this is all learning that comes back from the field, and I think the useful thing is to reflect about how people experience using these tools in practice. And I think however much we might say, yeah, it's a great tool and here's the manual and just do it this way, if people come back all the time and say, yeah, but actually it's just really quite hard. It's just much easier if you do it this way. I think, as academics, we have to kind of learn from that. Which I suppose is a bit more, like policy experience coming into play. And this was just kind of illustrate that when they worked it in Ethiopian multi-village systems, you actually got some similarities with the very small water supplies. So management and governance remained actually really problematic, even when you went to these bigger multi-village systems. But where you got better with the multi-village systems is you were much less vulnerable on your supply chains. Your supply chains tended to be more resilient. And that's probably a good reflection that once you get to that scale, your purchasing power increases and your ability to signal to the market the things you want to buy and to develop multiple providers of your services substantially increases. But again, this is stuff that's been fed back to government, both national government and local government, to spark that debate within Ethiopia about, okay, we talk all the time about resilience in Ethiopia. What does this mean? What do we now need to focus on? And that sort of gives you the kind of set of quite specific recommendations that come out of these exercises that go back into stakeholders. So it's not just broadly saying, yeah, you need to sort out supply chains or whatever. It's getting down to quite specific things about these are the kind of things we need to do. We need to look at the skill sets, we need to improve supply chains, we need to think about bill collection. So, a few reflections on that lessons that we did from How Tough Is Wash was that it's a framework that works much better for water supplies than for sanitation. That's partly a scale issue. So if you think about a water supply, even a small water supply, community supply, it tends to be one bit of infrastructure that actually serves quite a lot of people. And the problem about sanitation, particularly low and middle income countries, is that that infrastructure is very dispersed because every household is responsible for their own sanitation. So it gets quite difficult. How many toilets do you have to inspect to work out how many, the resilience of sanitation in a particular community? I think it's also because we understand climate effects on water and water supplies much more fully and much better than we do for sanitation. Because also a lot of sanitation low middle income countries is below the ground. It's subject to slightly different types of climatic threats than some water supplies. They're often less obvious, and it's certainly been a lot less well studied. But we are doing some further work around sanitation resilience indicators, and I'll talk about that again in a little bit. If you want to have a look at the manual, we do have a manual that's available online in both English and Spanish. So please go look at that. And I think one of the lessons we took out from the climate storylines was that they didn't work that well as storylines, and you needed to convert them to think about climate risk narratives as a more accessible tool for decision makers. Okay. So I think it's clear that these assessment processes are helping sector agencies think through much more about what they want to do about resilience, but is that leading immediately to action? I think the jury is still out. I think it's probably still quite early days. I mean, this metric's only been around for a couple of years. Others, particularly colleagues I work with in Australia, have been working on it for a similar amount of time. And I think we all come back with a similar kind of conclusion that we're still very much at the awareness raising, the sort of capacity building, the knowledge building around the sector. It's not ultimately immediately springing into action. Although I think SNV in Mozambique did actually use it, and that did lead to action, but they just weren't very good at communicating to anybody what the results of their actions were, which was slightly frustrating. In the end, I think we will need to do some intervention evaluations. We actually need to start seeing more sector agencies put in place programs to build resilience and then to evaluate that and to look at how much that is genuinely building resilience moving forward. One of the sort of things that people would need to think about, so at the moment, a lot of what people would say is you think about how you integrate climate considerations into existing risk management tools like water safety plans and sanitation safety plans. And that is happening certainly in high-income countries. So the Seattle example I gave you before is a good example of that. The Dutch have some good examples, as the Scottish Water. I would say at the moment, my concern is that the climate considerations get very embedded in just the risk assessment phase, the hazard assessment phase, and it's not being integrated enough about then thinking about how you design your corrective actions and how you define critical limits that you will measure on your safety parameters. There's certainly more and more attention given to adaptive management and adaptive investment strategies, and again, Seattle is quite a good example about this because they have trigger points about what levels of change they would need to see before they then decided to really think about changing reservoir operating rules, where they would think about building new reservoirs, where they would start thinking about rerouting sewer lines, and where they would relocate wastewater treatment plants. Certainly emergency preparedness plans need to be more fully developed, and that's something that, as I say, I think remains quite weak. And with small systems, I think there's a general sense that those will need much more centralised support to be effective. So I mentioned we also started to look more at sanitation. So this is through the SCARE project, which is a 4-year project funded by the Gates Foundation, which Bristol leads, working with Kathmandu, Haramaya, and Chambogo University, Chambogo's in Uganda, and Ecole Polytechnique de Taïs in Senegal, as well as Leeds University, University of Technology Sydney, and the Global Green Growth Institute. Field studies in multiple countries, which are both looking at empirical data, so collecting data on greenhouse gases in the field from on-site sanitation, from septic tanks and pit latrines, which is the first time that's really been done in a little bit of countries, and developing new resilience metrics, which are much more focused on sanitation. And that being underpinned by development of a groundwater inundation model, which is using a mixture of existing empirical data from countries, but also brace data to work out what level of inundation you start to get in your containers. I just thought I'd put in a couple of pictures. So I'd said we're measuring greenhouse gases. So basically, these involve developing of a flux chamber, which in the case of Senegal literally was a modified version of a bucket. It was slightly more sophisticated in Nepal, and then repurposing field equipment that's used for landfill gas monitoring to be able to detect CO2 and methane direct emissions from tanks and from the trees. Well, we were also going to do nitrous oxide. Unfortunately, we ended up by trying to repurpose equipment that's usually used in hospitals, and that's just not sensitive enough to detect environmental concentrations of nitrous oxide. I can't say too much about it. There's a couple of papers there. So this first paper is a review of approaches that have been done to try and measure greenhouse gases from on-site sanitation globally. The second one is a groundwater inundation model. Essentially what we are doing at the moment is analysing the data. So there was 2 years of data collected from each of the sites to capture seasonal variation. What's interesting is that there are signals of seasonality within that. So wet seasons, slightly more methane than dry seasons, but it's in quite a few cases, it's not statistically significant, which tells me that it's actually not an external driver that is creating the anaerobic conditions. It's an internal driver. It's the amount of liquid that's going into the containment as opposed to groundwater inundation. Certainly finding sanitation type is affecting it. Counterintuitively, in quite a few countries, the pit latrines are providing more methane than the septic tanks. And it's probably because the septic tanks aren't septic tanks, they're just holding tanks and they leak all over the place. Location being very important. So in Nepal, for instance, a lot more methane in low-lying areas. If you go up to the mountains, very little methane because the pits are very, very well drained. And we're working still on a resilience metric, and we're hoping to get a paper out around that early in the new year, which will try and give a better sense about how you look at that for on-site sanitation. What we're also increasingly doing is moving away from storylines into climate risk narratives. So this guy, Joe Darren, works Met Office. He also has an academic appointment at Bristol. He's helping us think through that. Using experience that they developed through the Fractal project in Southern Africa, as a way of trying to work with stakeholders to combine, think about futures, both in terms of a climate future, but also in terms of a socio-economic future. And it's basically on the understanding that the climate might look very different in 50 years' time, but then so will our society, so will our capabilities, so will our infrastructure. Early stages on this, but we have some major workshops planned for next year for Nepal and for Ethiopia and probably then also Uganda. And I'm hoping that those will provide stakeholders a better way of conceptualizing or not conceptualizing, a way of actually understanding what these climate threats will actually mean for them in their day-to-day job. Actually, okay, well, what does it mean I might need to start thinking about doing differently on Tuesday that I haven't thought about before? Because it still remains quite a challenge to get people to do that. Within Scale, we're also increasingly thinking about how do we manage emissions from sanitation. So it's very clear that on-site sanitation is a substantial source of emissions. There was quite an interesting study done in Kampala. It was published a couple of years ago by colleagues from Leeds, who suggested that sanitation in total contributed roughly half the entire carbon footprint of Kampala. I think that's an overestimate. It's driven by some choices they made about global warming potential of methane and various other things, but nonetheless, our empirical data is also showing that these things do actually kick out an awful lot of methane. And actually, it's the containments rather than transportation and scope 2 and 3 emissions that is actually important. It's the direct scope 1 emissions that come out of the tree, which is the big driver. So that was the thing about managing the systems. A lot of that basically is just moving the ship through the system as quickly as you possibly can so it doesn't go anaerobic. But you still need to capture the methane. So it's fine to move it all the way through to the system, but if it still ends up in the treatment plant with no methane capture, you're still getting a lot of methane being kicked out into the atmosphere. We're also starting to look and think about net zero and think about when you have sectors that don't own land, how can you start to look at things like inset and sequestration? So in Scotland, where I live, Scottish Water is doing a lot of work at the moment because they have a public body's duty to achieve net zero. And so they're looking a lot around imaginative ways to inset. Letting people build wind turbines on land that they own but claim the carbon credit for it, as well as looking at restoring peat bogs, wetlands, reforestation that is the more traditional forms of sequestration. So those are some of the kind of obvious options that you can have. You have your methane capture, you have better sludge management, improved energy efficiency, a lot of potential for generating energy from within the system. There's a whole water treatment plant in Edinburgh that drives itself basically on within system energy generation because they took out pressure relief valves and put in little turbines instead to generate electricity and then take off the power and to run the system. But I think one of the big messages that we're trying to give people as a takeaway is that you need to recognise with sanitation that some emissions are non-discretionary. Because actually the best way to stop methane being produced is to just have everybody defecating in the open. Because it's nice and aerobic. But we're not going to do that because that would be really silly because that would make everybody very sick. But you will be surprised how often you have to reiterate that to people in the wash sector, say, please, 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 don't get so obsessed about methane and getting climate finance. Remember, we need to do this for actually some pretty good public health reasons. But that's the big thing I think that I would take away, and I think that's true of quite a lot of sectors. And it's true also of the health sector. There are certain emissions that end up by being fairly non-discretionary. And what you then have to look is, well, how else you decarbonise your economy to cope with that. The reason I put this in is that I think if there's a lot of attention around water sanitation about getting climate finance, that this is the new holy grail that everybody wants. You keep saying it's going to be quite hard. You're competing against some very big ticket items that will have much bigger reductions than you can ever possibly achieve in waste. But methane and the methane pledge is possibly one thing because what we know about sanitation is it is a substantial source of methane. And the COP26 methane pledge potentially could be a driver, and that we know that there is some talk about the US coming in with a fairly major announcement in its current COP. I don't know if they've done it yet. Well, most of that money undoubtedly will go around to fossil fuel sectors, but again, there's possibilities that sanitation can create the argument that if you change practice, we can reduce methane and we can make a positive contribution to meeting that. So, sorry, it's probably spoke a little bit longer than I wanted to, but I was getting quite excited about this. I think some key takeaways I'd like to sort of leave you with. So the first is the assessment of resilience of basic services, including community managed very small systems in Africa and Asia, or the remoter parts of the Scottish Islands, is actually feasible. You can do it. So for many years, people were saying, oh, we just don't know. Actually, we do know. We do know how we can assess resilience. We can collect data in a way that will help decision making. And that there are real values about converting those into metrics that help people make decisions and not just leaving it very woolly and vague. Obviously, those systems need much more testing, much more refinement. I don't claim that how tough is wash is the be all and end all. I would love to see it evolve. I'd love to see it get better because more people do it and they find better ways of assessing resilience. It was put out there because nobody else was talking about it. I think what that's done, what we've managed to do is to get people talking about it. Sanitation will always be more complex than water and is always going to have messier metrics. It will be more difficult, always, I think, with sanitation. And as we move forward, net zero and how water and sanitation contributes to net zero is going to be the next big challenge about how you achieve that. So I think, thank you very much. Unhelpfully, I didn't put the full web address, but if I share the slide and you click on it, you can get there. And just before I finish, the reason for including this is from spring Chitwan in Nepal, and you can't really see it, but actually this pond is absolutely full of frogs, which is the reason why I actually took the picture. Anyway, thank you very much. I hope that was helpful and interesting.
Pretty much, we have a very short amount of time for questions, but if you have any questions from the room or online. Yeah.
Could you tell me a little bit more about how you calculate or quantify those metrics, the 1 to 5? What actually underpins that?
So it depends on the different sectors. So different domains, sorry. Yeah. So when we're looking at infrastructure, it's specifically around using visual inspection tools is what we use. So it was water supply, so we used sanitary inspection, so we were able to look at specifically the state or the sanitary condition of that infrastructure. Interestingly, you can start to apply it to other forms of infrastructure. So we started to develop it for bridges and roads in places like Nepal as well. The geospatial is that's quite quantitative as well. So it's looking for hazards within the catchment that you could identify. So you're looking at things like evidence of landslipping scars, evidence of deforestation. So those are all quite quantitative. The other bits tend to be more qualitative. So you do have to, it's a judgment based. So you're asking people questions. We do use surveys, so you can use some quantification through that with the right questions. I would argue sometimes the qualitative things are more useful because they give you greater insight. So those bits do require a fair bit of interpretive judgment. And what we try to do in guidance is to try and give a sense about how you do it. But it's probably the bit that people find hardest because people struggle around qualitative data much more than they do with quantitative data.
I know you said that you're moving away from sort of climate storylines and more into climate risk assessments, but for the climate storylines, how did you factor in the breadth of climate change? Because obviously we don't know if people are going to get better at reducing their emissions and what the future will hold. So how did you factor in whether those floods are going to be 1 in every 200 or you're going to get that extreme freak event happen?
So it's a very good question, and basically the answer within it is why we're going back to climate risk narratives. Because what we were able to do was we used, I think it was, the CMI P6 ensembles at an early stage to run likely changes primarily in precipitation but also in temperature in Ethiopia and Nepal over a 30, 40 and 50 year timeline. What you can then start to intuit from that when you start to look at, particularly when you start to focus on frequency of very heavy rain events, so you're looking at the 99th percentile and above, you can then start to intuit how much flooding you're likely to get. But what you can't do is to go from that, what we couldn't do with what we did, was go to the next stage about saying, would that be a 1 in 200 year or a 1 in 300 year flood? Because basically the hydrological data that's available in those countries is just inadequate in order to make those kind of link-ups. So the climate data is good enough, but the but hydrological data is nowhere near good enough. Which is really why then the storylines don't work that well. Because you're still hedged with too much ifs, buts and maybes. Whereas a climate risk narrative, I think, is an easier way of trying to put that out as a more qualitative assessment about you're going to get more of the very heavy floods at this time, and then align that with your way of thinking about socioeconomic development. But the short answer is it's very challenging because, as I say, while climate data might be good, hydrological data across the globe is pretty rubbish outside of high-income countries. It is very difficult to really understand what's going to happen.
Thank you.
I think that is all we have time for today.